Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, my name is Bakthi Ananda Harisona with name or student ID 24343085. Now I will be presenting a topic about tree, a topic in discrete mathematics. Okay, then first we will go to the introduction. Pardon a few misspelling. This time we will focus on a particular type of graph called a tree. What is the definition of a tree? The definition is a tree is a connected graph with no simple circuits. Trees are often defined as undirected graphs with the property that there is unique simple path between pair of vertices. In a tree, there is no simple again. In a tree, there is no simple circuits. Uh, then again, there will be about rooted trees. A rooted trees is a tree which one vertex has been designated as the root and every edge is directed away from the root. Okay? Then there is also a classification in here. A few that is like parent, child, sibling, ancestor, descendants, leaf, internal vertex, and subtree. Parents is a vertex with an outgoing edge to another. Child is a vertex that has a parent. Siblings, vertices sharing the same parent. Ancestor, vertices on the path from the root to a given vertex. Descendants, vertices that come from a given vertex. Leaf, a vertex with no children. Internal vertex, a vertex subtree that has a children. Subtree, a vertex and all its descendants, forming a smaller tree. Okay, and then there is a few notes I add here. Ordered root tree is a root tree where the children of each internal vertex are ordered. In the ordered trees there is also something called ordered trees. There is a rooted trees where the children of each internal vertex are ordered. This is an example of a tree, as you can see here. As the explanation, this is a tree, as you can see. Sibling is the that share the same parents. We can see here. Okay, then next. Then we will continue to to look at a tree as a model. Tree as a model in area like chemistry, computer, geology, and so on, so on, so on. They are using trees as a model here. Here are some examples that I've been written. There is one such as saturated hydrocarbon and trees that is used in chemistry represent to represent organization, tree to represent computer file system, and also tree that connect parallel processor. Okay, then next we will have to know the properties of a tree. Here I take uh, uh, from an article from GoKM that is from Singapore Mathematical Society. Here are some of the properties. First, a tree is a connected graph which contain no cycle as a subgraph. And then let G be a connected graph, then G is a tree. If and only if every two vertices in G are joined by unique path. And then the third properties is let G be a connected graph of order n and size m. Then G is a tree if and only if m equals n uh, dikurangi 1. Then on the fourth property is let G be a connected graph. Then G is a tree if and only if every edge in G is a bridge. And then Let T be a tree having pi vertices of degree I, which where I we will represent as 1, 2, and so on. As we can see here, this is the representation of the explanation here. Pi equals 2 plus p3 plus 2p4 and so on. Okay, then we will go to the next section. There, here we will explain. I will explain the application of trees. The application of a trees is such as like one binary search tree, two decision tree, three prefix code. Next, we will look at the image of this application. But first, I will explain what it is first. First, binary search tree. This is used for searching algorithm that finds item efficiently, which is a binary tree in, in which each children of a vertex is designated as a right or left children. No vertex has more than one right children or left children, and each vertex is labeled with a key, which one of the items. Oh. Then we have decision tree. Decision tree is a rooted tree in which its internal vertex correspond to a decision, which a subtree at these vertices for each possible outcome of the decision is called a decision tree. And then the third one, we have prefix code. A prefix code is a coding system where no characters code is the prefix of another, ensuring that each bit string sequence can be uniquely decoded. And then again, there will be a four. There is game trees. As the names as the name explain, the, the name explain itself that the tree can be used to analyze certain types of games, such as tic-tac-toe, name checkers, and so on, so on. Here, we will look at the image. First, this is binary search tree, or we can say just say it as BST. This is the explanation here before, and this is the image. This is a decision tree, which here can we look there is correspond to a decision. Here it is, and then the second one, and the third one is a prefix code. We can look at the image that represented, and the last one, such the image suggests itself. It is a game of tic-tac-toe. That we will. This is a game tree, and then we will have tree traversal. In the first, what is tree traversal? Here, there is. I explained that tree traversal is the process of visiting all nodes in an ordered root tree to access or evaluate data. Here is the universal address system. You can look at the image and the explanation here. Universal address system is a method for numbering nodes in an ordered root tree based on left to right children order. And then again, uh, in the in the tree traversal, there will be a traversal algorithm, of which it will be the method of how we will traverse the tree. The three most common algorithm is such as pre-order traversal, in-order traversal, and post-order traversal. That will be explained after this. We can look in the next section that I will explain about these three traversal algorithm, such as this. This is the pre-order traversal, this is the in-order traversal, and this is post-order traversal. We can look at the image too and the explanation. Okay, I will explain that. Pre-order traversal. This is follow to left, then right. The the root node of a subtree is visited first, next the left, finally the right. Just like this explain. In this one line, it explain everything, and then in order. In order, there will be left, the left visited first, then right is visited last. And then again, the difference between pre-order and in order is like pre-order started in the right. Uh, sorry, pre-order started in the left. It is the same as in order traversal, but the difference is the route here. The route node is visited first, but in order traversal, root node is visited after left subtree. Okay, then we will have the post-order traversal in the last one. Post-order traversal follow the left-right root order. In this one line, it also explain everything. First, it visit the left subtree, and then right subtree, and then root will be visited last. And okay, the next section is spanning tree. Okay, then in this section, I divide the explanation into three parts. First, what is a spanning tree? Second, how is a spanning tree obtained? And then, what is spanning tree for? Okay, what is a spanning tree? A spanning tree is a subgraph of a connected graph that include all vertices without forming cycles. And then again, how is it obtained? We can obtain a spanning tree by removing edges from a cycle. And then, after we obtain it, what is a spanning tree for? This is are some of the application I obtained, such as pardon for again the misspelling. First is computer networks, two is multicast routing, and etc. etc. Okay. In spanning tree, there is something also known as DFS or depth first search. In this explanation, I divided into a few parts again. First, what is DFS? Depth first search is something to explore graph by going deep into a path before backtracking. And again, backtracking, I will explain it later. After this, there will be a section for backtracking itself. And again, what is DFS for? DFS is used for finding spanning trees. This is the short explanation for it. And then again, for DFS, there is also few edge type such as 1, 3 edges, 2, back edge. Okay, we will go to the next section. There is again BFS. Uh, the same as different as DFS. BFS is used for constructing spanning trees. And then again, what is BFS? What is BFS first? BFS is also known as breadth first search. That is to traverse a graph level by level from a vertex to its neighbor, then their neighbor, and so on. It's also a void cycle by only adding edges to the new vertices. I add as a note here. Okay, then to the next section: spanning trees, the backtracking, and the application. What is backtracking? Backtracking is to explore all of the possible solutions. Backtracking if a path is invalid. Example of its application is such as graph coloring, queens, submat sum. Backtracking often combined with DFS that we can see here before. Here, DFS is a depth first search is to explore graph by going deep into a path before backtracking. Here I added a note. Okay then, for the last topic, I will talk about minimum spanning tree. Minimum spanning tree, or we also call it MST, is a fundamental concept in graph theory used to design cost-efficient networks. For instance, imagine a company wanting to connect 5 major cities using telephone cables, with each connection having a different cost. The goal here, the MST, is to connect all the city with minimum total cost without forming any cycles. In graph terms, MST is a spanning tree of a connected weighted graph that has lowest possible total edge weight. And then this is the algorithm. First, there will be a Prim's algorithm, then there will be a Kruskal algorithm. But first, I will go with the Prim's algorithm. One of the most widely used methods to find a minimum spanning tree is Prim algorithm. It starts from a single vertex and gradually add the smallest weight edge that connect to a new unconnected vertex. This process continues until all vertices are connected without forming any cycles. Since it builds the MST progressively, from one point, Prim algorithm is especially suitable for dense graph where many edges connects the vertices. This is the explanation for the Prim's algorithm. Okay, then we will go to the cross-call algorithm. The cross-call algorithm is another efficient approach to finding an MST, the same as Prim algorithm. This is another approach. Unlike Prim method, the difference is Crystal begin by sorting all edges by their weight and then selects the smallest edge that doesn't form a cycle. This process continues until all vertices are connected. Since this method is not tied to any starting vertex and evaluates edges globally, Crystal is more suitable for sparse graph where the number of edges is significantly lower than the number of vertices. That is the explanation for classical algorithm. But then again, for more specific, what is the difference between Prim's algorithm and classical algorithm? Here I will go about the differences. Here is it. Uh, here I just take two main differences such as main focus and best use case. In the main focus, Prim algorithm focus on vertices, and then Kruskal, sorry for the misspelling here. Kruskal algorithm focuses on edges. And then for the second main differences is first, Prim algorithm is ideal for dense graph that has been explained earlier is suitable for dense graph. And then again, Kruskal is ideal for sparse graph. This is very different to each other because first, this is so dense that is ideal to use it, but then this is more ideal to more sparse. That explain here significantly lower. Okay, I guess that's all. I will explain about trees in discrete mathematics. My name is Bakthi Ananda Harisona with NIM 24343085. Uh, thank you very much for the one who is watching. Assalamualaikum warahmatullahi wabarakatuh.